Hi everyone, we're going to use GEBS, Gaussian elimination with back substitution, GEBS is my term, in order to solve systems of linear equations. And after this, you can do the first two problems on the homework to get some practice, and then I'll show more examples next time. Named after Carl Gauss, but the ancient Chinese knew it. Okay, let's assume in our class we have a square system, n linear equations, and n unknowns. So the coefficient matrix will be n by n. In our class, mostly 2 by 2 or 3 by 3. Write the augmented matrix, the first one, then use EROs to write a sequence of row equivalent matrices until you get one in the form we like. This is an example of what's called row-echelon form. We'll talk more about that later. But one of our favorite row-echelon forms is this. We're aiming for ones along the main diagonal. We love that coefficient. 0, we love that even more. That corresponds to eliminating, right? Eliminating terms. Zeros all below. And then these other entries can be wildcards. You could do it one way, your friends could do it another way, and you might have different entries in here. And the matrices could still be equivalent. In a way, this is the target. It's kind of like the right-hand side of a trig identity. Now, generally speaking, you try to correct the columns from left to right. Hopefully your matrix won't be this big, but the idea is that you want to get column 1 right, 1 and then a string of zeros, column 2 right, wildcard 1, string of zeros, then column 3, and so forth. The idea is that, hey, if you've just cleaned the floor, you don't want a person with dirty shoes walking in. Why not? Because you don't want your good work to be undone, right? If your first column is good, you want to keep it good. Okay, now let's assume that you can achieve this form. Bear in mind, if the solution set is empty, for example, you cannot achieve this form. This form is only available if the system has one unique solution. Okay, so write the new system complete with the variables, your x's, y's, and z's maybe. Right? Use back substitution to find the values of the unknowns. Write your solution. Presumably, it's one unique solution as part of a solution set. Optional step, you can check. It's not required, but wow, you feel really good if your solution checks out. Try out the first two problems on the homework. And by the way, you might want to quickly check each of your steps before proceeding. As you'll see, these problems are vulnerable to avalanche effects. Avalanche effects, my term. What do I mean by that? If you make a mistake early on, it tends to snowball. So you might want to check your steps along the way. A single mistake can have massive consequences that are difficult to correct. A check will make you feel really good. Again, you can try the first couple of problems on the homework. We'll do some more examples next time.